The title of this video should be, can we have this? The title of this video should be How Not to Store Passwords. Thank you. Because you really shouldn't store passwords yourself if you can at all avoid it. If you are running any kind of web service and you are storing passwords, it is so incredibly easy to get it wrong that basically you shouldn't try. If you can use sign in with Facebook or Twitter or Google and get them to handle it for you, for crying out loud, please do. If you're a web programmer, sooner or later you're gonna have to store passwords, and this is the ways not to do it. If you want to know the ways to do it, I will kind of say that at the end, but please look up a recent tutorial for the language you're using. By the time you watch this video, the advice will have changed. You may be watching this years in the future. Look up a tutorial that's been written in the last few months by someone reputable and follow that. How do you not store passwords? The first instinct, the naive thing, is just store the user's password. So let's say you have a sign-up box and you have a username and password box. The naive thing is that when a user signs up, you take their password and you store it in the database, as it is in plain text. That has a couple of advantages. First of all, if they forget their password, you could just email it to them. And it means that checking it is really simple. When they log in again, you take their username, you take their password, and then you take what they've just typed, you compare it to what's in the database, and if it matches, you let them in. And that is the naive approach to storing passwords. And there are still professional websites out there run by big corporations that still use this strategy. And you can tell that they're using this strategy because they email your password back to you in plain text when you ask for it. This is a monumentally bad idea. This is an astonishingly bad idea, because if someone gets into your database through a security hole or because they're an insider with access, and let's be honest, if you're storing passwords this way, you probably have other security holes too, then they can just read out every user and their password. So you have their email address and you have their password, and let's be honest, most people reuse the same password for their email address on websites. So this is a bad idea because it's incredibly insecure. Approach number 2. Slightly less naive, still a bad idea, is you take that password and you encrypt it. So you hide it behind something. And encryption is two-way. So encryption is something that you have a key that will lock something and then unlock it again. So the naive approach is you take the user's password, you take it into your database, encrypted like this behind the thing you've locked, and then, it says Chinese hand, when they log in again, you take what they've got, you go here, you unlock this, you compare them, and then you let them in. Now that's a little bit more secure because if someone just reads out the database, you've got an encryption key there, but it's got a couple of big flaws. First of all, as soon as that key's available, the password's still visible and can still be read out. And it means that an insider, or even a hacker in some cases, can just take the encryption key as well with them, and they've still got access to all the passwords. That's a pretty bad idea. The other flaw with this is that if you have lots of people using the same password, and if you've got a big site, this will happen because lots of people will use 12345 or password 1, and if I've just said either of your YouTube passwords, go change it. If you have that, all the encryption will be the same. So even if you don't have the encryption key, you can still tell that all these people have the same password, so it's probably a common one. Adobe just made this mistake this month as we record this. Adobe, the big company behind Acrobat, which makes PDFs, behind Photoshop, behind all the big tools, millions and millions and millions of users, their password database got breached. Gigabytes of passwords lost. But it's fine, they said. Mine. Yours? Yeah, mine was as well. Fortunately, I didn't use that password anywhere else, which is what you should hopefully be doing. Their passwords were encrypted, and that was it. It was just a lock on it. And it meant that everyone who had the same password had the same encrypted code. Unfortunately, they'd also stored all the password hints with them, which is which is wonderful, because then you can look, oh look, there's 20 people who've used the same password here, and that one says Michael Jackson as the password hint, and that one says Halloween, and that one says type of movie. Oh look, it's thriller. Okay, wonderful, it's thriller. And that's one of the biggest software companies in the world didn't do this properly. Anyway, so don't use encryption. Naive attempt number 3. Hashing. Now, I talked about this in an earlier video. A hash is a summary of a load of data. So let's say you have the password the user enters, and you know that when they enter it, you're going to hash it. And you're going to put it through some kind of convolutions that ends up like that. And then, when the user enters their password again, mutates it in the same way, compare, they're the same. Which is great in theory, but unfortunately leaves you open to the same problem that Adobe had, which is that if you can tell a common password, if it's in loads of people's database entries, you probably can work out what it is. Worse than that, as I've said before, Google has an index of these things. If you're using a basic hashing algorithm, you can pretty much just type the code into Google and it will give you the password back. As well as just searching for common hashes on Google, there are these things called rainbow tables, which trade off computation time for hard drive space. So rather than having to calculate millions and millions of hashes for this one password, someone has already done it for you. Calculated hashes for billions of common passwords and just put them out in a database. It's gigabytes long, but it's a lot easier to search through that than it is to try and do a load of calculation. So if you're using something common, like MD5 or SHA1 with nothing else added, the rainbow table will pretty much help you crack that in a few seconds. I have in the past used all those naive approaches myself on things I've built in my youth. I've gone back and fixed them where they're still alive and just sort of quietly buried the code where they weren't. But the approach nowadays is to use something called hashing and salting. As I said, the best thing is not to store passwords at all, but if you have to, the advice these days is hash salt. So a salt is a random string of characters that is different for every single user. It's a password you know in your database. You can store it in plain text, it doesn't matter. The user could even know it, not that it would help them with anything. That means when the user registers, they put their password in, and it goes into the same algorithm, but as well as that, you generate a random string of characters for each user, completely random. A new second password, if you like, that goes in the database. And that gets fed into this algorithm too. So that comes in, mutates it a bit more, comes out with something else. So if another user uses the same password, that algorithm will get a completely different salt from them. Some people might base it on the username, but that's generally a bad thing to do. It should just be a random string of characters. So the same password going in for a different user will mutate into something entirely different. The point of this is that now you just have a random string for each user. You cannot possibly pull the password back from this. It won't appear in Google because it's a massively long random string. You can't brute force it back by looking at what common passwords are reused. All you can do is do the old style attack of trying every single common password one after the other. And if your salt's long enough and your hashing algorithm's complicated enough, then that's really incredibly difficult to do. Do it right, and it's lifetime of the universe difficult to do. Or at least it is, until they use the password 123456. If you change one byte, one bit, anywhere in the file, at the start, at the middle, at the end, then the whole hash should be completely different. This is something called the avalanche effect.
This very complex signal is not just dependent on the bit pattern that was last written to the drive, but it actually depends on what was there previously.